In the previous section, we looked at the disk and washer method, which was useful for finding the volumes of revolutions about a horizontal axis. In this section, we're going to look at the cylindrical shell method, and the shell method is useful for if we're trying to rotate some sort of area about a vertical axis. And so what we're going to do is we're basically going to use circumferences this time instead of areas, and then multiply it by the height. So you can see like each of these concentric cylinders right here. Okay, so these are what we're looking at. And notice that there's like a width between each of those. All right. And the more width, the more error is going to be. All right. So ultimately, what we'd like to do is we'd like the distance between each of those to be 0. Okay, theoretically. All right. So, but that would mean that theoretically we'd have an infinite number of these shells. So we're going to first of all use a circumference, which remember is 2 pi r. And then what we're going to do is we're going to multiply it by the height. All right. So to be able to get what we're going to find is basically like what are the shells. The shell is going to be equal to 2 pi r height, right? But in this case, if we kind of think of this as like the x-axis, that the distance or the radius of the shells is actually going to be the value of x. So wherever we see these r's, we're going to replace it with x, and we certainly know that the height is f of x. So another way that we could write the shells is going to be 2 times pi times x times f of x. And of course, we want the distance between those to be theoretically 0. Okay, so we could basically say like that's a delta x. And so ultimately, we get a Riemann sum, okay, just by adding those all together, and then we end up with the volume. Okay, so just a reminder that the shell method is good for, or more useful, if we're rotating about a vertical axis. Okay, the disk method is if we're rotating about a horizontal axis. Okay, now we are going to see later in this section that we could be able to use one or the other to be able to evaluate any volume. But again, just to make it easier on yourself, just remember shells are for vertical and then discs are more for horizontal. All right, so given that, let's go ahead and see if we can find some volumes. Right. So this time, what we're going to do is we're going to start off with a fairly elementary function, y equals x minus x squared, bound in the first quadrant. Okay, so x equals y equals 0 is really the same thing as like quadrant 1. And we're going to revolve it this time about the y-axis. Okay, and the y-axis has formula x equals 0. So we know that our volume is going to be 2 pi integral from a to b of f of x times dx, right? Certainly we know the function. The function is x minus x squared. And so the only thing we really need are the bounds. In quadrant 1, this is essentially what we're looking at, okay? And what we're doing is we're looking to rotate this about the y-axis this time, not about the x-axis. And so what we really need to do is we need to figure out these 2 points. All right. Now, clearly in quadrant 1, I think everybody can see that this is going to be 0. But to find the other point of intersection with the axis, we're just going to have to set the function to 0. Right. So x minus x squared equals 0. All right. We can factor out an x, and we get 1 minus x inside of our parentheses is equal to 0. And so that means that one value is 0 and the other value is 1. All right, so our integral for the volume is going to be 2 pi integral from 0 to 1 of the function x minus x squared times x dx. Now we're just tasked with being able to evaluate the integral. We're going to distribute the x, right? So that way we can prepare this for integration. So we have 2 pi integral 0 to 1 x squared minus x cubed dx. Right? Now we can integrate term by term. This is going to be 2 pi 1/3 x cubed minus 1/4 x to the 4th from 0 to 1. Really nice that we have 0 and 1 in there. So this is now going to be 2 pi times 1/3 times 1 cubed minus 1/4 times 1 to the 4th. If we substitute 0, it's going to turn it into a 0. Right? So really, we just end up with 2 pi 1/3 minus 1/4. We can get a common denominator 12 here, or you just throw it into our calculator at this point. So we would get, if we get a common denominator of 12, we would get 4/12 minus 3/12. And so realistically, this just works out to be 2 pi times a 12th, or pi 6. So that's our volume. Okay. All right. So that's our process. Okay. Not meant to be too difficult, at least for this first one. Okay. So again, we go through, we use our formula for the volume, okay, using the shell method because we are revolving about a vertical axis this time. Okay. And then from there, we just go through, use our techniques of integration to be able to evaluate. For the rest of this section, we're just going to look at various sorts of problems that evaluate volumes rotated about axes, either using shells, or we're going to go back to the disks and washer method just to kind of compare when it's more useful to use one versus the other.